Howdy, everybody. Mo Moore with Industrial Networking Solutions. We're just going to briefly walk you through our edge solution project that we did. ARB found INS through, I think, the Ignition website. We're an Ignition integrator, but mainly we're a distributor of industrial technologies. The things that we talk about with like Ignition on the edge with the Moxie units, Advantech, using the Cirrus Link modules embedded with the Ignition platform. We are very much in that house. So we do distribution. Sure. Yeah. So we do a lot of the distribution of the hardware, pre and post sale support, and then we also have a services group, and that's kind of where I'm at, is in our services group. I manage the software services side of it, and then we have a traditional networking side of it. So Jerod, you want to kind of talk about like how our project got started, and then we'll jump through some of the stuff about how we selected the edge devices.
Yep. So ARB Midstream made an acquisition of a gathering system in North Texas, southern Oklahoma, and about 900 miles of active pipe. Didn't have necessarily a proper SCADA system in place. Didn't necessarily even have a proper IT infrastructure in place. So basically, we're going from a server in a closet type company to having a full-blown regulated system that we needed, proper SCADA, basically a fully operational system, and we had basically 6 months to do it. So I knew it was impossible, but you got to try, right? So I've built traditional infrastructures before. I know what it takes to do all that stuff, and there was no way that we could have basically made it work in the time frame that we had. So I've been introduced to kind of the IoT space and edge computing and all these different technologies. I figured, let's leverage everything. Let's use the cloud. Let's use software-defined WAN for our networking. Let's use edge compute and basically create an infrastructure from scratch and develop a SCADA system from scratch. Previously to reaching out and understanding Inductive Automation's Ignition, where they already had edge technologies, I was in the process of creating a custom solution with developers, because I didn't see and I wasn't really aware that this was out there yet. The edge compute existed. So I was like, I'll be real fun and do it myself. Well, of course, with working with developers, all that stuff, we fell behind, plus the time crunch that we had. Spoke to some former colleagues of mine. They said, hey, this Ignition thing, it's already got kind of what you need. So that's what we did. So reached out to INS here and basically said, hey, this is what we have. I know it's not possible. Let's give it a go. So that's what we did.
Yep. So kind of leading back to that, what you're seeing right here is the overall architecture of what we built out. So when Jerod contacted us, we looked at it and he said, I want to be AWS. That's quite what I feel comfortable with. I've seen that their platforms are very stable and solid. So INS also specializes in helping customers get that infrastructure built out, and we're real competent on selecting the right edge IoT device, what protocols you're going to be using, and then what software packages at the edge, and then the software into the cloud. We do prefer the Ignition side of the things because we've just found that it's much more integration friendly, and that we have a lot more solutions we can offer and build off that scalability wise. So what you're seeing here is, we essentially needed to, I'm going to take you back to some considerations here at the end of the presentation, but we needed the IoT at the edge. In this particular instance, we used the Moxie UC8112. We did not need cellular because we ended up using the Cradlepoint solution because of the NetCloud Perimeter SD-WAN technology. Has anybody seen the SD-WAN technologies that are out there? What SD-WAN is? It's software-defined wide area networking. It's a really cool way that when we looked at this, Jerod said, I need to be able to see my end devices behind the IoT edge device. I need access to control that. I need the data to be pushed to the cloud, and I need to be able to manage that in an efficient way. So we said, well, you have a lot of remote assets. You really need to consider the fact, because you're doing this over cellular, One, we need dual SIM technology, so we need multiple modems out there, so you can go AT&T or Verizon for automatic failover. And then, also with that is, let's talk about what your bandwidth utilization is going to be. How much data are you going to be pushing? And, I said, I really think you should look into the MQTT Spark-Plug-B protocol, because we can really get that traffic down. And we've been doing it for a while. We've been working with serial link solutions with Ignition, and it's a really plug-and-play solution that I think will really help out. So when we first started that, what we did was we architected this solution where we had multiple layers of redundancy throughout the entire process. So if you're looking here at the bottom level, you'll see that the IoT gateways have two different distributors, two different brokers they can see at any given time. And if one loses one in the one region, it can flop over. The others will all float to the other. So we scaled out the tiering of the AWS instances to make sure they could handle the workload of all the remote assets. But then we load balanced them, because why not? We have the two servers out there. Data flowing into the instance is not billed against you. It's data flowing out. So then the second thing we took into consideration was redundancy at the application layer. So, working with Arlen and his team, what we looked at, we said, well, if we split the engine out, we only need to have it at a redundant level at the Ignition side. We'll have two distributors for redundancy. And now, because the engines are pointed at the different distributors, we have two different servers set up on one engine. When that fails over, it just takes the configuration with it. So now we have multiple layers of redundancy, application and at the IoT level. So then the next thing we did was we said, well, we've got a lot of clients that are going to be connected to this thing, and we don't want to disrupt the flow of traffic of the data up. We want that to be a nice, consistent process. So we segregated client host level and the perspective modules, where they were doing a lot of HTML stuff, off to one instance of its own, and then we put another engine on it, because the whole point of MQTT with the pub sub is, one, report by exception, good data management, compressed packet levels type stuff, right? But the second piece is that we can have the data engine doing its thing with the alarming system and everything that it can collect the data and see the tags, but then you can do the host and make it completely separate of that entire process, but it can still receive the data because it's part of the conversation. So we have the single source of truth at the bottom. We know where the data is coming from. We have store and forward now and redundancy at the bottom, so that if we happen to somehow lose the entire AWS infrastructure, which would be scary because I'm pretty sure that's a worldwide bad event going on, but we had the multiple layers of redundancy. But what this also did was give us the ability to do maintenance. So now, as we're running into issues, or if we want to do something to the servers, if we need to beef up the instance. So in the case, if we need to take the app server and increase resources, we can fail it over, and then we can do our work on the servers and then fail it back to the primary. Same thing with the instances over here. If we need to work on one, we simply kill the networking to it, work on the instance, redeploy it, bring it back up, and now everything's talking and we never lost a beat, right? And then if for some reason we do have to take the entire thing down, we just store and forward down here, right? And the beauty of the MQTT side of it is, if you've ever seen the store and forward model there, is that you can take that packet level detail with the embedded timestamp and everything in that packet that's transmitted, so you know that the data is coming back up, as long as you've done good management on the edge, is going to be accurate, right? So, and then everything, of course, went to an RDS instance in the cloud, so we weren't managing the database. We didn't have to worry about that, do routine backups, and everything's good. So that was the overall architecture. This is a good example of what one of our networking panels looks like. This was pretty much every panel that you see at the edge. And so INS architected it. We worked with Jerod to make sure that this was what he wanted and fit the footprint that he was looking for. So in here, you'll see that there's a managed Cisco switch, a cradle point modem, dual modem with AT&T and Verizon SIMs. On the left-hand side over there, you'll see the IoT gateway. And so all of that was your compressed network box out there in the field. But in doing and looking at this, what I wanted to talk through a little bit in our presentation was, considerations of what you're looking for when you're talking about edge devices, right? So always consider protocols at the edge. What drivers do you need? Allen Bradley, Siemens, Modbus, because there's a lot of scalable software packages that will integrate with Ignition, right? And a lot of them have the Spark-Plug-B protocol or just generic MQTT JSON. Horsepower, remote analytics, HMI, just protocol conversion, single core processor on an ARM single core processor with 1 gig of memory. you're only going to be doing protocol conversion, right? Because if you try and do analytics or anything that's going to push that any more than that with multi-threaded, operations, you're going to run into problems, right? And you're going to have startup issues and things. And then, the multi-purpose device, right? And what we're talking about with the multi-purpose device is it going to be an HMI? So do I need peripherals on it and things like that? And if I do, what kind of heating and cooling things do I have to worry about because of peripherals? And then also, when we talk multi-purpose device, you've seen the onboard program out there from the inductive guys, right? But we also, when you look at the onboard program, we're doing things where we have Steam radios that have ignition edge preloaded on them. Cisco edge switches that have ignition loaded on them because it's a Linux platform. So imagine that. You no longer have to have 3 pieces of hardware to do one thing, right? You can stick a radio, a point-to-point radio, picking up 3 miles of traffic where you may not have been able to get a cellular coverage, but you put a low-cost antenna shooting 3 or 4, 5, 6 miles across on a point-to-point, and ignition edge is living on that radio, right? So things to think about with multi-purpose devices. Common platforms for scalable, supportable solutions. Look for devices that have good operating systems like Debian 9 and things like that because it gives you scalability and you can add third-party tools behind the scenes. And then keeping costs down without losing performance and redundancy. You saw from that architecture drawing, we were able to take, a single core ARM processor with 1 gig of RAM. That box is fairly inexpensive, but it had all the features we needed, and then we built in the redundancy based off of the MQTT redundancy built in with the Cirrus Link transmission client, and then the redundancy all the way up to the cloud with the design. Cloud platform designs, we get asked a lot, even if we're not doing the projects, to come in and help cost model, cloud-hosted solutions. Jerod has been really great on that. He's been helping us. When we started the project, we had to ask him a litany of questions. How many average tags you have? How many are analog? How many are discrete? Because when we are doing the MQTT protocol, we can look at that and we can re-gauge the calculation between things that aren't changing, right? Alarm bits and things like that don't change very versus analogs. So you need to build a cost calculator for the type of tags you have, the tag count, and be able to say, okay, this is what it's going to cost me to run this. And remember, data in is typically not your cost, it's data out, right? And then design for data model efficiency, different tiers. So as an example, what we did with what Jerod set up is we looked at it and said, well, the MQT distributors are not running application layer stuff. It's simply doing the movement of the data, right? It's the MQTT server. So we put that on a tier small level with, the medium, and we just made sure we had a dual core and 4 gigs of RAM, and it's run perfectly. We've had no problems with it. Several hundred units talking to each one of those servers, and never once have we had any resource problems. The larger application servers, we beefed that up to a tier 3, large. But then the client system, the client instances, we beefed that up even more to a tier 3 X large because we knew we were going to have a lot of clients connecting, and it was going to consume more RAM. It was going to have more application licenses. It was going to be it needed to be a beefier instance, right? Database model, always considering your database modeling, what your connection rates are going to be, how much data you're going to have, sizing it, because you don't want to get to a point where you're not keeping an eye on it and then have to resize it during, heavy loads as you scale more solutions to it. And then plan ahead for scalable solutions. So we're real big on infrastructure as a code. Basically building CloudFormation templates so that you always have your templatized servers. If I'm going to spin up another IoT gateway, it takes me seconds to do it, right? And then I can back it up. If I have a problem with an instance, we can shut it down, redeploy it, put our backups in, and we're up and running in minutes. So build, design, deploy. We did a cloud-hosted solution, TLS encryption, distributed model with redundancy, recover model with backups, CloudFormation templates, and then redundant communication paths. We went through that. Here's just some examples of some of the installations with the cellular side of things. The data model. So this is the example of report on exception, the data flow, and then back to the control center. And then this is our solution stack. So you can see when you're doing things like this, it's not one piece of hardware or software. This is a solution stack that represents ARB midstream solution. So you can see the edge technologies, Solve Networks, Cradlepoint, Cisco with the managed switches, and the Moxa IoT gateway. AWS was our selected cloud hosting solution with inductive automation and the CirrusLink modules. And then we had a third-party auditor that helped us, check and make sure that our services were set up right with AWS. Okay, I think that's it. And Jerod?
So just kind of close real fast on that. Impossible odds, impossible timeline. That's how we all operate. Our goal date was March 1, and we finished February 28th, like at 10 o'clock. I'm not kidding. It was that close. So we got it all done, got everything point-to-pointed. We were a fully regulated operating pipeline. So really neat. We leveraged all this stuff, a lot of long hours, a lot of late nights with Mr. Mo on the phone, kind of checking everything out. But I'm confident that over 5 years ago, you probably, without all these technologies that we leveraged, it wouldn't have been possible. So go from zero infrastructure to complete OT infrastructure from scratch in 6 months. So that's all I have.
Thank you.